Good evening, everyone. Till now, students have. Am I audible to you guys? Please, someone clear that. Hello. Is my voice audible?
Yes, ma'am.
Okay, okay. Since I'm not well today, though, so I'll be speaking a bit slower today. Okay, so till the time everyone else joins the class, can we have a bit interactive session for like 5-10 minutes? Would you guys like to introduce yourself to the class? Sujit.
Yeah, good evening. I am Sujit.
Okay.
Uh,
And where are you from?
I am from JK Lakshmi Cement. I am General Manager Safety and heading the safety function here. So,
Okay.
with my
Very nice, Sujit.
own interest, I joined this course.
Okay, that's very nice to hear that you have joined this course just because of your interest. And what about others? Harsha, Omkar, Elisa Khanam.
Yes, ma'am. My name is Milton Ahmed. I am from Assam. I'm doing MSc in botany.
Okay. Hi, Milton. Okay, I think we'll wait for 3 more minutes and we'll start the class at around 6:10. Today we'll be having discussion for your assignment for week 3, and I hope you all have attended the lectures for week 3 by now.
For BP,
Yes, ma'am.
Hi Harsha, good to see you again.
You too, ma'am.
Harsha, in the last class, you have asked a doubt in one numerical, right? So in by the end of the class, I've covered that question. So I hope you got that. Okay, so shall we start the class now?
Yes, ma'am.
Yes, ma'am.
Okay, I hope the screen is visible to you guys.
Yes, ma'am.
Yes.
Okay, so good evening everyone. And today we'll be having your weekly tutorial session for week 3. And we'll be discussing the assignment questions that were given in the last year. Okay, so the first question is, according to the Pascal-Gifford stability classification, the stability class E is among all these following options. First one is very stable, second is slightly stable, third is slightly unstable, and fourth one is neutral. So, any idea about this? I hope you all must have gone through this stability classification in your class. Anyone? Okay, so let me tell you about this classification. According to this Pascal-Gifford stability classification, we have classified this stability in 6 categories. First one is for the stability class A, the nature is very unstable. For the class B, it is moderately unstable. Similarly, for class C, it is slightly unstable. For D, it is neutral. For E, it is slightly stable. For F, it is moderately stable. And for the stability class G, it is extremely stable. So we have asked for the stability class E. So it will be for E,
Slightly
it will be
stable.
slightly stable. Correct. Apart from this, there are some other factors as well. How do we take the how do we consider which kind of stability classification is there? So it depends on the like what time of the day that we are considering, and also what kind of insulation is there, also the surface wind speed at the height of 10 meters from the ground. So when the wind speed is less than 2 and there is strong insulation, then the stability class will be A, that is very unstable. And similarly for moderate, it will be from A to B. For slight insulation, it will be B. I think this topic must have been covered in your class in very much detail. So just remember this table and this thing. It will be helpful in your questions when the stability class is not given and you have to consider one of the stability classes. Okay, now coming towards the next question. Excuse me. Identify the type of plume based on the figure given below. Here DALR is the dry adiabatic lapse rate and ELR is the environmental lapse rate. And the options are option A, looping, option B, coning, option C, fumigation, and option D, lofting. So in your class, you must have
Looping.
read which one?
Looping.
Looping, correct. And can you please tell me about the type of stability, about the type of environment when the ELR is this one and the DLR is this one? What kind of environment is supposed to be there? Is it unstable,
Turbulent.
turbulent? That means it is unstable.
Yeah.
Okay, let's see. Excuse me. Okay, so would you guys like me to take this topic in a bit detail, like about the types of plumes and the plume behavior? If you want, I can discuss this topic once again. It will be a quick revision to you guys.
Yes, ma'am.
That will be
Okay,
helpful.
okay, okay. To understand the type of plume and the plume behavior, first of all, we have to understand the classification of the environment, like what kind of environment is there as per the lapse rates. As I've covered this topic in very much detail in the last class, those who were present in the last class must know this, that how we consider the environment. Like if the dry adiabatic lapse rate is more than the saturated, this will be the general case. In every case, the DLR will be more than the SLR, and these two are more than the ELR. That means the air parcel is changing its temperature at a higher rate as compared to the environment. Then the atmospheric condition will be absolutely stable. It will have absolute stability because the parcel will be at a lower temperature as compared to the environment, and hence no dispersion. The parcel will sink down and it will contract. Similarly, if the ELR is more than the DLR and which is more than the SLR, then the stability classification will be absolutely unstable. And here the dispersion of the particle will be maximum. Similarly, when the ELR is between the DLR and SLR, then it will be a condition of conditional stability. And when the ELR is equals to the saturated adiabatic lapse rate, then it will be wet neutral. And further, when the DLR is equals to ELR and which is more than SLR, then it will be dry neutral. All this have been covered in the last class. And when the ELR is negative, this is very important. When ELR is negative, so when this ELR is negative now, then this is the condition of inversion, and in the condition of inversion, extreme stability is there. Now coming towards the plume behavior and the types of plume. So we'll be covering 7 types of plume here. First one will be looping, second is fanning, third is coning, fourth one is lofting, fifth is fumigating, sixth is trapping, and seventh one is the neutral plume. So all this classification will be based on the situation of the adiabatic lapse rate and the environmental lapse rate profiles, and also uh, where in some cases we will also consider the inversion of the ELR. So for the first one is the looping plume. In this case, basically the strong instability condition is there because the ELR is more than the ALR, so that atmosphere is strongly unstable, and hence the dispersion of the pollutant, as you all can see, there's a very much dispersion of the pollutant, like on a large scale. So due to this, basically with distance it dissipates very rapidly, and this is a condition of super adiabatic lapse rate, and it is for unstable conditions. Here the ELR is more than the ALR, and this is of wavy nature. So in vertical excuse me. Okay, so that since the atmosphere is unstable, so rapid vertical air motions will occur both upwards and the downwards. So the area, like it will be a bigger as okay, so the area that it will cover now, that will be maximum dissipation that is occurring in this case. And as a result, large pollution concentrations may rise near the ground. And the solution for this type of environment is to create a much higher stack, so that if this stack is higher now, if this stack is higher, so then this thing will shift towards greater height. and thus we can at least avoid the concentrations at the ground level. See, if the stack is higher, na, then this condition will occur. So at least at the ground level, the pollution concentration will be comparatively lower. Now, coming towards the next one, we have fanning plumes. So this type of, first of all, sorry. Okay. So first of all, this type of plume is observed to be there when the surface inversion conditions are there. Basically, ELR is negative here. ELR is negative. So what will happen here is the since the ELR is negative and this inversion condition is approximately at the height of the chimney. So what will happen? There will be like a straight line dispersion of the pollutants, and this can be visualized as a narrow horizontal fan, and the no vertical spreading is there. Basically, there will be no movement upwards or downwards. Only horizontal movement of the pollutants will be there. And if the effluent is warm, the plume rises slowly. And like for example, in some cases when the effluent is warm now, so the condition can also be there that like when the plume rises first very slowly, and then it will start to dissipate horizontally like this. This can also be a condition, but it will always dissipate in like in horizontal lines. No dissipation will be observed vertically. And the temperature profile and stability here is the that the ELR is negative, and it has an inversion condition, and the atmosphere is very stable. So these kind of plumes are formed at extreme inversion conditions owing to a negative lapse rate. And when the environment is under conditions of inversion, a stable environment occurs just above the stack, as explained. A stable environment occurs just above the stack, and the plume moves horizontally rather than upwards. No upward movement will be there. And this occurs more frequently when there is less turbulence, because when there will be turbulence, then it may like disturb the movement of these particles or the air parcel. So might be possible when there will be turbulence, then a little bit of dispersion will be there. For stack height, fanning is considered a favorable meteorological condition, as it does not cause ground pollution. Because since the horizontal displacement of particle is there, so what will happen is since we are releasing uh, the air parcel or the pollutants at some height from the ground, so what will happen is and there is no vertical movement of the air parcel, so the ground level concentrations will be very much lower, and that's why this is considered as a very favorable condition as far as the ground level pollution is considered, because the dispersion will be at a much higher distance, as well as in after several kilometers the dispersion will occur. So this is a favorable condition. Now, the next one is coning plumes. Okay, so what is there in coning plumes? The dispersion are in the shape of a cone, and here the temperature profile is nearly neutral. So that is why it takes the shape of a cone, and the axis is horizontal. Here the lapse rate is near neutral, and one more thing is there, that is the wind speed is more than 32 kilometers per hour. This cooling plume will be there when the wind speed is more than 32 kilometers per hour. This condition should be satisfied because at this condition there will be much higher turbulence, and this will help help in having such kind of dispersion of pollutants like this, the shape of a cone. So basically, these type of plumes are formed when the horizontal wind velocity exceeds 32 kilometers per hour, and the cloud blocks solar radiation during the day and terrestrial radiation during the night. So that is why there is very little vertical mixing, and the environment is slightly stable under subadiabatic conditions. Here the ELR is less than the ALR, and the plume shape is also symmetrical about the vertical horizontal plume line, that is this one. You can see that the shape is very much symmetrical about the axis. Now the next one are lofting plumes. Okay, so next one is lofting plumes. Here what was what condition is there? uh, there is a inversion condition below the stack. So there's inversion below the stack and unstable environment above the unstable environment above the above this inversion condition. So what will happen is the particles will try to disperse above this stack height. Since there is inversion, there will the movement down below this inversion line will be restricted, and that's why the dispersion will be concentrated in this region only. So that is also a good condition because the ground level concentrations will be very much lower in this condition. The dispersion will be in upward direction, and here the adiabatic lapse rate at the top and above, and inversion condition is below the stack height, stable lower layer with neutral or unstable upper layer. Clear? So basically, lofting plume is produced by a strong superadiabatic lapse rate immediately upper above the stack, which is which means that it will be strongly unstable, and a negative lapse rate inversion immediately below the stack opening. That is why the downward movement is stopped by inversion. This results in a very rapid and turbulent upward mixing of the plume, but the downward mixing is less. As a result, the dispersion of the pollutants become quick, and pollutants cannot come down to the ground. Such a plume is good for dispersing air contaminants and providing significant protection to the living beings. Now, the fifth one is fumigating plumes. It is just the reverse of the lofting plume. Here, what happens is the inversion layer is above the stack height, and the strong superadiabatic lapse rate occurs at the stack top and below it. So what happens is the inversion layer is above the stack height. This is the inversion layer, and below this it is the unstable atmosphere. So the maximum dispersion of the pollutants occurs below the stack height, and that is why the ground level concentration of the pollution will be very much higher in this condition. Here the fan or cone with well defined cone and dragged or diffused at the bottom. There will be adiabatic or super adiabatic lapse rate at the stack top here and below that, and isothermal or inverted lapse rate above this, that is inversion condition. That is why the lower layer is unstable or neutral and the upper layer will be stable. So the fumigating plume is the exact opposite of the lofting plume. and it is formed when there is a negative lapse rate or inversion just above the stack and a strong superadiabatic lapse rate below the stack. Here, the pollutants cannot escape above the stack under these conditions, thus, they settle downwards to the ground due to the turbulence and mixing. As a result, the dispersion of contaminants in a fumigating plume is exceedingly poor. Here, the dispersion of contaminants is very poor because the maximum dispersion is occurring below the stack height at the ground level. So where this kind of plumes are observed, basically these are observed near the coastal areas. Next one is the trapping plume. This kind of plume is observed when like there is inversion layer above and below the stack. So the pollutants are kind of trapped in between these two inversion layers. They can't move upwards or downwards. So this kind of plume is called as trapping plume because the pollutants are trapped in between these two layers. So there will be horizontal movement of plumes with no vertical mixing, and the adiabatic lapse rate between the two inversion layer is there. Basically, the atmosphere is unstable in between these two layers, and above and below, and these two layers are the basically inversion layers. So when an inversion layer exists above and below the stack, the plume does not rise or fall. Rather, it is constrained or trapped between the two inversion levels, and this is a result in a trapping plume. This plume isn't optimal for pollution dispersion since it can't go past a particular height. That's why there will be very minimal dispersion of the pollutants. Next one is the neutral plume. Here, the temperature profile and stability is the near neutral lapse rate, and thus there will be like a vertical axis. The cone shape with a vertical axis is there, and this plume dissipates upwards. In neutral atmospheric circumstances, where ELR is equals to the ALR, a neutral plume is formed, which rises vertically in upward direction, and this plume will continue to rise until it reaches a height where the density and the temperature of the air parcel is equal to the ambient air or the surrounding air. So, for the question, I think I haven't marked this. Huh. So, in this kind of environment, we'll be having a looping plume. Now, for the next question. The bottom 10% of the atmospheric boundary layer is called as, first option is surface layer, second is stable boundary layer, third is residual layer, and fourth is mixed layer. The bottom 10% of the bottom 10% of the atmospheric boundary layer. Which one is this?
Surface layer.
Correct. It will be surface layer. So basically, the atmospheric boundary layer is the bottom layer of the troposphere, and its width is about 1 to 2 kilometers. That is in contact with the surface of the Earth. And like the major components of the atmospheric boundary layer are, first is this surface layer, second is mixed layer, third is the residual layer, and the fourth one is the stable boundary layer. So the bottom 10%, as can be observed, this will be the surface layer. Okay, so for the next question, as per CPCB recommendations, the minimum value of the chimneys or the stack height adopted for industries except for thermal power plant is, I
30,
think, which one?
30 meter, ma'am.
30 meters, correct. Okay, so I've also added this table, the minimum values. So basically, these are the recommendations as per the CPCB. So the for the chimney adopted for the industries in general, except for the thermal power plants, it will be 30 meters. And for the power plants above 200 megawatt watt and below 500 megawatt capacity, it will be 220 meters. For thermal power plants having greater than 500 megawatt capacity, it will be 275 meters. So here it is for, except for thermal power plant, it will be 30 meters. Okay, one thing I would like to ask to you guys, that why is this difference is there, like for all the industries in general we are taking 30 meters, and for the thermal power plants we'll taking such higher values, that is 220 and 275 meters. There must be any reason behind that now. So do you guys have any idea why this difference is there?
Ma'am, emission of the pollutants
And
is high,
not
ma'am,
the
compared.
NOx generation is there. That's why the stack height is kept higher.
Yeah, correct. Basically, the emissions as compared to the other industries in the thermal power plants, the air emissions are very much higher. So that is why
Yeah.
this difference is kept here.
So, ma'am, if the plant
Yes.
capacity is in between, say for example, 18 to 200 megawatt, then what will be the stack height? Is any formula for calculating that?
Like for the thermal power plants which are having capacity less than 200
Less
megawatts.
than 200, yeah, ma'am.
Right now, I don't have any idea. I think,
Because we have the thermal power plant of 18 megawatt and the stack height is 90 meter.
yeah,
So, is there
I
any
think
calculating that?
right. Right now, I don't have any idea for that, but I can definitely check that and revert back to you in the next class. How do we calculate the stack height for the thermal power
Thank
plants
you,
which
thank
are
you,
less than this? Definitely, I'll
thank
tell you in the next class. Okay, so shall we proceed towards the next question?
Yes, ma'am.
Okay, so dash is the number of times monitoring data is obtained and recorded over a specified time interval. Basically, हम कितनी बार किसी एक मॉनिटरिंग डेटा को ऑब्टेन करते हैं या फिर रिकॉर्ड करते हैं एक स्पेसिफाइड टाइम इंटरवल पर. तो व्हाट इज दिस टर्म नोन एज? फर्स्ट इज मेजरमेंट टेक्निक्स, second is indicators of performance, third one is monitoring frequency, and fourth one is averaging time. Which one will
ma'am. It
be?
is averaging time.
Just read the
Averaging time.
question once.
Monitoring frequency.
Correct. I think this will be monitoring frequency. Let's see.
Yeah.
Yeah. So it will be monitoring frequency because basically frequency is what? The number of times that you are recording certain value, na, that is its frequency, because the time interval is fixed. For example, let us say for the air quality measurements. So, for example, if we are recording the values for a short term duration, for example, like for a 6 hour period of time, we are recording certain values of the pollution. So, like how many times that we are taking the data now? For example, let us say we have for a 6 hour period of time and we have set the interval to 1 hour. So, in every 1 hour period, it will record one value. So that is its frequency. Like for the period of 6 hours, it will record like 6 times it will record the values. So that is its monitoring frequency. Basically, the number of times the monitoring data are obtained and recorded over a specified time interval, that is its monitoring frequency. And the examples of monitoring frequencies include like at least every 10 seconds for COMS, at least once per operating day or week or month, etc. for CPMS, work practices or design inspections. Let us move towards the next question. Okay, cities in which the ambient air concentrations have consistently exceeded the national ambient air quality standards for a period of 5 years are called as which वो cities जहाँ पर जो आपके national ambient air quality standards है वो constantly exceed हो रहे हैं, हम उन permissible limits को meet नहीं कर पा रहे हैं for a constant period of 5 years. तो उन type of cities को what do we call them? Attainment cities, non-attainment cities, mega cities, and green cities. Which one is there?
Yeah, mega cities.
No.
Non-attainment city.
Non-attainment. Yes, ma'am.
Correct.
Non-attainment.
Non-attainment. Basically, the term is self-explanatory. Non-attainment is something that we cannot attain or we are unable to reach. So, since we are unable to attain that standards now, so that is why these cities are termed as non-attainment cities. Basically, a non-attainment area is any area that does not meet either the primary or the secondary or national standards for the ambient air quality as directed by the Clean Air Act, which was last amended in 1990. So, like these NAQS are set by the US EPA, and these are measured by according to the pollutants in the area, including emissions that are both natural and human caused. And as discussed in the previous class, that EPA has set the national ambient air quality standards for the 6 principal pollutants, which are called the criteria pollutants. And these 6 pollutants are ozone, lead, nitrogen dioxide, carbon monoxide, particulate matter, and sulfur dioxide. Okay, so the next question is, when an air pollution index gives a false alarm, even though concentrations of all the pollutants are within the permissible limit, except for one pollutant, it is called as, first is eclipsing, second is ambiguity, third is maximum operator approach, and fourth one is minimum operator approach.
Ambiguity.
Ambiguity. Anyone else? Okay, I'll take both these terms, eclipsing and ambiguity, in a bit detail. So basically, there are two important characteristics regarding the air pollution index. First one is eclipsing, and second is ambiguity. Basically, they are very significant to interpret any index in the right perspective. So, eclipsing occurs when the air pollution index does not indicate poor air quality, even though concentration of one or more air pollutants may have reached unacceptably high values. So basically, in this condition, what happens is, see, there's a certain formula to calculate the air pollution index. So while calculating the index, there might be possible some conditions where the values of the individual pollutants are exceeding their permissible limits. But when we calculate the index, that is within the permissible limit. So that is why there is basically they the indicator or the AQI is not indicating the poor air quality, but there are certain pollutants which are exceeding their permissible limits, or they are unacceptably high values. So in this condition, the pollution is underestimated because the pollution is there, but since we are measuring only the AQI, that is why the we are not realizing the correct level of pollution. So this term is known as eclipsing. And ambiguity is just opposite of that, because here ambiguity occurs when the air pollution index gives a false alarm, even though the concentration of all the pollutants are within the permissible limit except for one pollutant. There might be a condition when like like one just one pollutant is beyond the permissible limit, and the AQI is giving a false alarm. All the other pollutants are within the permissible limit. So in this case, the pollution is overestimated. Basically, the we are not having that much pollution that is being estimated by the AQI. So that is known as ambiguity. Now the next question. If the AQI value comes to be 169, what would be the AQI category as per CPCB? I think in the last class or in the class before that, we have discussed this AQI and like the categories defined by the CPCB. So if the AQI value is 169, what category will be there? Satisfactory, moderate, poor, or severe?
Satisfactory, ma'am.
Satisfactory. Let's see the table. Basically, this is the table. These are the values of the AQI. For the value of 0 to 50, the category is considered as good. For 51 to 100, it is satisfactory. 101 to 200, it is moderate. When the question it was given as 169, I think this will be moderate. For 201 to 300, it's poor. And 301 to 400, it's very poor. And above that, it is severe. So the classification of air quality models based on the coordinate system is basically based on the coordinate system. This classification is termed as short-term and long-term models, reactive and non-reactive models, grid-based and trajectory models, screening and refined models.
Grid-based and trajectory models.
Yeah, correct. Okay, so let's discuss like all the classifications. So based on the time period, the air quality models are differentiated as the short-term and long-term models. The short-term models will be for a few hours to a few days. Like basically, these will be the worst-case episode conditions. The long-term models are to predict the seasonal or annual average concentrations. And for example, if we are calculating the health effects due to certain exposure conditions, then we'll go for the long-term models. Next is based on pollutant type, primary and secondary models. So based on the pollutants, when we are discussing the primary pollutants like the or the non-reactive models, the pollutants considered as particulate matter, SO2, carbon monoxide, etc. And for the secondary pollutants, reactive models such as ozone formation and dispersion. Next is based on the coordinate system. So there will be grid-based and trajectory. In the grid-based model, basically a whole region is divided into an array of cells to determine the compliance with the national ambient air quality standards. And for the trajectory models, we follow the plume as it moves downwind. And based on the level of sophistication, there is a screening model where simple estimations are there, worst case meteorological conditions to provide conservative estimates. The next one is refined models. Here, the more detailed treatment of physical and chemical process, and this requires more detailed and precise input data. Next is air quality modeling in urban regions using an optimal resolution approach. Aurora model is based on box model, Eulerian model, Gaussian model, and Lagrangian model.
Gaussian model.
No, anyone else? Okay, so These are the types of dispersion models. For some of the examples of dispersion models. For box models, examples are Aurora and CPB and PBM. So for the Aurora, this will be box model. Gaussian models will have Colleen, Highway, Car FMI, Air Mod, ADMS, and so on. Lagrangian and Eulerian models will include GRAL, TAPFM, PALM. CFD models will include Area, MISCAM, Microcalculate, Atmos. So we are done for the questions for today. Now we'll take your doubts if you guys are having any doubts in any topic. Please feel free to ask if you are having any doubts.
Ma'am, good evening, ma'am.
Yes, Harsha.
Ma'am, what is this box model, Gaussian model used for? Ma'am?
Actually, these are the different types of models that are used for the study of dispersion of air pollutants.
Okay.
Basically, the Gaussian plume model, it is used to find the dispersion of pollutants that are being emitted from a stack. And I think these all the topics will be covered in the class as well, and we'll be also having numericals on these Gaussian models as well. So these are basically used to find the downwind and the crosswind concentration of the pollutants.
Thank you, ma'am.
What is lapse rate? There are three types of lapse rate we see, but what is lapse rate?
Basically, lapse rate is the rate of decrease of temperature with respect to height. So, for example, जैसे हम अर्थ के सरफेस से upwards मूव करते हैं vertically upwards, तो with height ना the temperature tends to decrease.
Yeah.
एंड तो वो किस रेट से चेंज हो रहा है फॉर अ पर्टिकुलर हाइट. फॉर एग्जाम्पल अगर हम 1 किलोमीटर मूव कर रहे हैं तो इनिशियल पॉइंट और फाइनल पॉइंट के बीच में क्या डिफरेंस है टेम्परेचर का, दैट इज योर लैप्स रेट.
मतलब
द रेट
temperature
ऑफ
variation with respect to altitude.
एग्जैक्टली द वेरिएशन ऑफ टेम्परेचर विद रिस्पेक्ट टू अल्टीट्यूड, दैट इज योर लैप्स रेट.
Yeah, thank you.
ओके, वेलकम.
Ma'am, in Gaussian dispersion model, there are three types, ma'am. Point source, line source, and area source. Why do we have three types of source?
So basically the okay, so sorry. So basically, the type of pollutant now, we have considered the like three sources of pollution, and that is a very broad classification. So, for example, the point sources that will include your stacks or some kind of industries where they're using these stacks. Na, so the concentration of pollution or the source which is dissipating the pollution na, that will be at different points in a space. So that is considered as the point source. Next one, for example, if we consider a line source. So visualize this as a, like, as we move on a road, हम रोड पे चल रहे हैं and at some place there is a traffic jam is there, so there will be a large number of vehicles that will be present there, and everyone is having its own like emission, or for example consider a car that is moving on a road. So what will happen is the pollution is not stationary at a point, it will be moving from one point to the other. So that is like, for example, if we consider the roads ना, वहां पर जो pollution होगा that is considered as a line source, because there are a lot of small points that are emitting the pollution, and if we club all that together, सबका impact हम एक साथ study करें, that is termed as a line source. Next, for example, if we go towards the area source, so what happens is if we join all those points, or if we join all those line sources parallelly, so what will happen is that will become an area source. वहां पर क्या होगा, एक large area को हम consider करेंगे, और हम assume करते हैं कि वहां पर से, like if there are small points, एक बहुत ही कम एरिया में बहुत सारे पॉइंट सोर्सेज प्रेजेंट है, तो rather than studying the impact of individual points, so what we do is हम उसका एक एरिया ऑफ इन्फ्लुएंस ले लेते हैं, और उस पूरे एक एरिया के लिए हम जो डिस्पर्जन होगा पॉल्यूशन का, और दी एक इफेक्ट ऑफ दोज पॉल्यूटेंट्स, वो स्टडी करते हैं, तो दैट इज टर्म्ड एज एरिया सोर्स.
Thank you, ma'am.
Next, I hope you guys are like having your lectures on time, or you guys are like going through all the presentations that are being given to you.
Ma'am, I don't understand what the air shed meaning. Can you please explain?
Airshed?
Ma'am,
Yeah, I think this have been covered in the topic assimilative capacity of an airshed, correct?
yes, ma'am.
Okay, let me find that presentation जहाँ से आपको visualize करवा सकूँ. Basically, like in a very general term, airshed is a geographical area which is very frequently affected by the same air mass. Basic और simple words में,
Ma'am, the definition is this part of atmosphere that behaves in a coherent way concerning the dispersion of air pollutants. But I don't understand how it behaves in a coherent way.
so basically what happens this na, and in an airshed na, the topography is such that the pollution dispersion is similar in that particular area. Whether the climatic conditions are such that the, or the like topography or the structure is as such that the that the level of concentration of pollution will be almost same in that particular area.
Yes, ma'am. Thank you, ma'am.
Anyone else? Okay, so before taking your doubts, I also needed to have a discussion with you all. Since I wasn't able to record your first class properly, so I was thinking to have the discussion for week one questions again. Apart from that, we can also take some other topics as well in that class. So like I was thinking of having that class day after tomorrow. Is that fine? And will you guys be able to join that class using the same meeting link that we are having?
Yeah, we can.
Yes, ma'am.
Okay, so see, since most of the students were there in the first class, so we'll be having a quick discussion of all those questions that were discussed in the first class. And apart from that, we can also take some topics that you want to discuss in that class. So if you guys want to discuss any topic or want a quick revision of any kind of topic, um, which is till week one. Yeah, till week one, or maybe we can go till lecture 10. Yeah, till lecture 10. If you want any topic to be discussed now, you just tell me about that, or just leave a comment in the chat box, and then we can have a quick discussion of that topic.
Can we share it on discussion forum later?
Yeah, sure, sure.
So we will go through the slides 1
Yeah,
to
yeah,
10.
definitely,
And
definitely. Also, uh, if you're not comfortable for I guess for day after tomorrow, then we can also have this class in the weekend also.
ma'am, time is not issue, not an issue.
Okay.
First, we need to
So,
go through all the slides.
okay, so no issues. I think take your time, take a time for 1 or 2 days, and
Yeah,
then let me know. And I'll also drop a message in this discussion forum about the class timings and the day for the class. Most probably we'll be having this class on Friday. Is that fine?
yeah, ma'am.
Ma'am.
Yes, ma'am. Fine.
Fine, na? Okay. So on Friday we'll be having one more class, and we'll be recording that class as well, because I wasn't able to record your first class. And we'll be taking some numericals as well, because I think this till now we have covered very much theoretical part. So I'll be taking some numericals as well.
That would be a great help, ma'am.
Sure, sure. Also, please feel free to ask any doubt or any kind of question or any topic that you want to cover, because see, this class is
Excuse me,
just
ma'am.
our Yes.
Ma'am, actually, basically, yesterday also we said to the same thing to Archita, ma'am. Today also, ma'am, I'm again repeating. Actually,
What?
ma'am, we have a request. Many of our students from this group are purely from biology background. So, like, we have some problem
Okay.
regarding all differentiation and integration. So, if you can take up a brief on those the basics of this, so that we can understand and do the numericals, that will be much easier for us.
Okay, definitely, definitely. See, basic differentiation and integration, I'll keep that in mind. That if any question or any condition comes where we need to differentiate or integrate those topics na, or that part of the question, so I'll definitely teach you first how to do that, and then we'll get into that question.
Okay, ma'am.
Okay, I'll keep that in mind. See, I want this class to be like this only, that any kind of doubt or any kind of problem that you are having regarding your subject, I'm there to help you guys out. See, if I know that doubt, I'll tell you, but if I know that question, or if I know the doubt that you are asking, then I'll let you know. And if I don't know, then and then also I'll let you know, because I'll first go through that topic by myself only, and then I'll teach you. So there's no issue. Just feel free, because I want this session to be more interactive. I'm also one of you. I'm also a student only. So I want this to be an open kind of discussion, not a one-ended conversation.
Um, Ma'am, I have another doubt, ma'am.
Yes.
There is one question that available assimilation capacity is given as permissible standard minus ambient pollution concentration. Ma'am, I don't understand. Ma'am.
Can you please type that in the chat box, because uh,
Yes, ma'am.
yeah, because I can't hear you clearly.
You are on mute, ma'am. We can't hear you.
Okay, so basically assimilation कैपेसिटी इज कि वहां पर कितना पॉल्यूशन एसिमिलेट हो सकता है, और कितना अभी पॉल्यूशन, कितने लेवल तक पॉल्यूशन वो ले सकता है कोई भी एक पर्टिकुलर एरिया. तो सिंस हियर इज अवेलेबल एसिमिलेशन कैपेसिटी, कि कितना एसिमिलेशन कैपेसिटी उस पर्टिकुलर एरिया में, उस पर्टिकुलर एयरशेड में अवेलेबल है, दैट इज योर परमिसिबल स्टैंडर्ड. परमिसिबल स्टैंडर्ड इज मैक्सिमम. जहां तक हम परमिटेड है, वहां तक हम पॉल्यूशन के लिए लेवल पे जा सकते हैं, दैट इज योर परमिसिबल स्टैंडर्ड. एंड माइनस एम्बिएंट पॉल्यूशन कंसंट्रेशन, जितना एम्बिएंट एयर में ऑलरेडी अवेलेबल है. इन दोनों का जो डिफरेंस आएगा, उतना ही लेवल तक पॉल्यूशन का जो एमिशन है, हम वहां पर अलाउ कर सकते हैं किसी भी एक पर्टिकुलर एरिया में. क्लियर कि मैक्सिमम रेंज जहां तक हम जा सकते हैं, दैट इज योर परमिसिबल स्टैंडर्ड. और ऑलरेडी जो एयर में प्रेजेंट है पहले से ही बाय डिफॉल्ट जो है वहां पर एम्बिएंट पॉल्यूशन कंसंट्रेशन, तो इन दोनों का डिफरेंस ही होगा जितना हम एसिमिलेशन कैपेसिटी, मतलब कि जितना परमिसिबल होगा उस पर्टिकुलर एरिया में एमिशन.
Thank you, ma'am.
Next, anyone else? Okay, right now you guys must be having like I just wonder that might be possible that you guys are having any doubts in any topic. So just why not you share that in the chat box. I won't if I won't take that now. For now, I'll take those doubts in the next class, or I'll take those topics in the next class. Are there any topics that you want to discuss again, or you want to like study again? Then we can take that in the next class, because the next class will be more sort of an interactive session, since we have discussed all the questions.
Yes, ma'am.
I think no one is having any doubt. Are you guys there or you just join the meeting and leave it like that?
Ma'am, yeah, there,
Oh,
ma'am.
yeah, yeah.
So is it like someone as Kajal Kumari? She's there. Yeah, I know. So I think Gurjar sir is teaching you very well because you guys are not having any kind of doubt in the class. Okay, if not for the current coursework in kind of any practical or field application, if you are having any doubt or any question that you want to ask.
Ma'am, can I ask one last doubt, ma'am?
Sure, 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 sure.
Ma'am, the buoyancy flux parameter, that I read the question, ma'am. The buoyancy flux parameter is utilized to calculate the effective height of the stack. So then they have given the formula, ma'am, but I don't understand what is the meaning of the buoyancy flux parameter.
Okay, just let me take that. Where is this? Just a second now. Effective height of stack. Okay, just a second. I'm just finding that presentation. Can you please share your screen or the point where you have that question? Basically, this term is used for the turbulence to understand the turbulence. So this uh, buoyancy flux parameter, which is when multiplied by a virtual potential temperature, then it gives a flux that is proportional to buoyancy, and buoyancy is related to turbulence in the atmosphere. So, then get your doubt clearly. क्या
Ma'am,
question?
I'm trying to show the screen actually. I'm just
Yeah, yeah,
the question.
yeah, sure, sure. Is it in the this week's assignment?
Ma'am, no, actually this is a week 4.
Okay, this is
We have
the
we have one more day in our hands. So that question I also left actually untouched. So that's now if the doubt is clear, then I can go for that one.
okay for week 4.
And this is the question number 5.
Just a second. Question number 5. The biopsy flux parameter F is utilized to calculate the effective height of the formula for the biopsy flux given below. Okay, where Vs is your exit velocity, ds is your start diameter, ts is exit temperature, and T is ambient temperature. Okay, so the unit of F will be, okay, so right now I don't know, but we can definitely find its unit now, because we know the unit of G. It will be in meter per second square. The unit of Vs will be like in meters per second. DS will be in meter and it is squared. Okay, just let me give me some time. 1 minute. I'll tell you the answer. See, sometimes you don't have to know the correct answer or the explanation. You just can see the options or just use your like common sense to, for example, what is given as F is equals to. Okay, why not you guys solve this question along with me? F is equals to G into Vs ds by 2 whole square, which is multiplied by ts minus ta divided by ts. See, here the temperature uh, in the numerator it is subtracted, and then which is divided by the temperature. So this will be having no units, the temperature part, correct?
Yes, ma'am.
So we'll be left with the unit of g, which is meters per second square, multiplied by the unit of velocity, meters per second, and this is multiplied by the diameter square, so that is meter square. So this will be meters to the power 4 by second cube. Meter to the power 4 by second cube. I think the option C will be the correct answer.
Yes, ma'am.
Thank you, ma'am.
Okay. See, biopsy flux parameter is nothing. It is just an indicator to understand the turbulence in the atmosphere. And since the formula is already given, so you just have to like multiply and divide the units and nothing more than that. Next question or any other doubts that we can take for today? Because see, anyhow, I have to take this class for 2 hours. So instead of just being here, being still, it's better to have some kind of discussion in the class.
Ma'am, why are there so many technical terms? We thought it would be very easy, ma'am, but we half the time we can't understand anything. All the words are so tough to understand.
Yeah. See, since this topic is such now that technical terms come naturally, but it is not necessary that for solving a question you must be knowing all the technical terms. See, I'll tell you my story. So during our examination time, when I used to prepare for my EAC or GATE examinations, so in EAC some questions were like that ki you sorry, you don't know the term that is being given, you don't know its formula, but just by visualizing or just by observing the options that were given na, I was able to solve the question. For example, like how I did it here, I wasn't clear about that term, but since I just wanted to I just had to solve the question, or I just had to find out the units. So what I did is just common, I multiplied and divided the units and then found out the answer. So you can't remember, or you can't like unless and until you put so much time or you put so much energy in one particular topic or in one particular subject, you can't be having knowledge about all the terms that are being given in that subject. So it's fine to not know something, but it's always good to like to have that aspiration or to have that interest to know new things. Every day you'll be having one or two new terms in your life or in your subject or in any kind of term. So it's fine.
Ma'am, I am currently doing MSc Environmental Science from IGNOU, ma'am, and I have enrolled in this air pollution and control for the project, ma'am. So what topic can I take? So can you suggest any topic, interesting topic that I can take as a project for my last semester, ma'am?
Okay, so I think, see, if you have access to like some kind of air quality monitors or in your laboratories, then I would suggest that you can go for the practical application, like some sort of air quality modeling thing or monitoring of the air quality, whether it is ambient or indoor. Basically, the indoor air quality monitoring, that is the current topic that I'm also working on. And monitoring of indoor air quality, that is a topic like burning topic for the current scenario. So if you have access to those equipments, and with that, if you are able to like monitor or to like extract some data, then you can do the modeling part. Or else, if you're not having equipments to record the data, then you can work on the ambient air. And because the data is very easily available on the CPCB website, Central Pollution Control Board's website, you can take any stretch or any particular area that you need to work on, and just extract the data from there and apply some sort of modeling approach. And you can also go for that as well if you want to work on the like topic of air pollution, whether it is ambient or indoor. That depends upon the availability of the resources, because not much data on the indoor air quality is available. So you have to first extract or the record the data, then you can move further.
Thank you very much, ma'am.
Welcome.
If I don't have any equipments, because I'm doing it now, so uh, if I don't have the equipments, and what other project can I take?
So no issue. If you don't have any equipment, then basic numerical modeling is always a good option. You you can have the data if you want to work on air quality or the water quality or anything. You have access to the data from the CPCB and SPCB, Central Pollution Control Board, as well as the State Pollution Control Board websites. They are right now they are giving tremendous amount of data, like for the river quality, for the air quality, everything. So just have that data and like use some statistical or other kind of modeling approach, and just formulate your results. That is fine for now.
So should I select in my home? You told indoor and ambient, ma'am. So can I do
Yeah.
it like inside my home or my neighborhood? How to?
See, if you want to work on the indoor environment, na, you need to have some kind of monitors, because the indoor data that is not that is not easily available on the internet. You have to record that data on your own. But for the ambient environment, the data is available, I guess. Yeah, it is available on the Central Pollution Control Board website.
So how do I use these models, ma'am? So just
See,
Gaussian model to use, ma'am. So there are so many models. You said box model, Gaussian model. So how would I know what to choose?
See, that depends on what sort of approach that you're going for. During my masters, I just use different modeling softwares are there. So first of all, just try to figure out which software do you want to work on. And for example, you can use MATLAB, you can use R, you can all use any kind of modeling softwares. So first of all, try to figure out your objectives. Try to formulate your objectives. What do you want to do? Then go for the options. Like for if you want to go for CFD modeling, then there is a software called ANSYS Fluent that is very good for CFD modeling. So just try to find out what you have with yourself, because might be possible that you are having your data but you don't have access to those softwares in your labs. So first of all, you need to be very clear with your objectives, then proceed forward.
Thank you, ma'am.
Welcome.
All the
Okay.
graphs are,
Yes.
sorry,
Yes,
all the
Harsha.
graphs are very, I mean, there are so many graphs, ma'am. How do we know which graph is important? It's very large number of data, ma'am. So graphs are so much, the diagrams are so many. We don't know what if we, I don't, it's very difficult to remember all the
What,
data.
what kind of graph are you talking about? Basically, what I was telling you about the raw data, that is, if you want, I can also show you the data that is available on the site.
No, ma'am, I'm
Just,
talking about our NPTEL course.
acha, okay. So,
The ELR, DALR, SALR data, and that I'm talking about
okay,
in
see,
NPTEL exam. So how?
see, you don't have to remember all the graphs and all the data. Just remember the important concepts. For example, the ELR and ALR. Once you understand the once you understand na, how to study the slope, because ELR and ALR is nothing just the slope of the line. तो आप उसको एक बारी correlate करना सीख गए ना, you don't have to learn all the graphs how it is. If you want, I can take this topic in a bit detail in the next class also. कि you just have to understand the slope of the line, और उसके अकॉर्डिंग आपको ELR और ALR के वैल्यू समझ में आ जाएगा. एंड आफ्टर दैट अगर ELR ज्यादा है, ALR कम है, तो अकॉर्डिंगली क्या होगा, उसके अकॉर्डिंग हम एटमॉस्फेयर डिसाइड कर सकते हैं. सिमिलरली जो टेबल्स आपको गिवन है, यू डोंट हैव टू रिमेंबर ऑल द टेबल्स एंड वैल्यूज. आफ्टर सम टाइम ना, जब आप क्वेश्चंस को एनालाइज करना स्टार्ट करोगे ना, देन यू विल गेट टू नो दैट देर आर सम इम्पॉर्टेंट टॉपिक्स. फॉर एग्जांपल, अगर आप गॉसियन प्लूम मॉडल में जाते हो, तो वहां पर हॉरिजॉन्टल डिस्पर्शन कोफिशिएंट सिग्मा वाई सिग्मा जेड, देयर इज वन ग्राफ फॉर दैट. तो वो ऑलवेज दैट विल बी गिवन टू यू. आपको वो ग्राफ कभी याद नहीं हो सकता, बट फॉर द स्टेबिलिटी क्लासिफिकेशन आपको एक अप्रॉक्स आइडिया होना चाहिए कि अगर ये विंड स्पीड है और ये कंडीशंस हो रही है, तो व्हाट विल बी द स्टेबिलिटी क्लासिफिकेशन दैट विल बी देयर.
Thank you, ma'am. So we can just refer to the smoke, or we can say fog. Why do we have this term plume, ma'am? So it's confusing, this word plume. So why do we use
Basically, see, both the terms are very different. Smoke or fog is different. Basically, fog, what happens? Fog is all over the area. But when we are talking about the plume, see, you must have observed some kind of chimneys ना. तो वहां पर क्या होता है? There is very much high concentration of pollutants in a very small area. Getting my point? Plume क्या है? Plume is a parcel of air that is loaded with the pollutants. That is plume. And fog is a general condition that is occurring throughout the area. So both are very different terms.
Yes, ma'am. The concept of inversion is they say it is stable, ma'am, but if it is stable means it is problem for us, no, ma'am. So
Yeah, it is a problem for us, but the that depends on the like height of the inversion layer. In general, if we have the inversion condition, that is very difficult for us because, as seen in the Delhi NCR region in winters, when we have the inversion conditions now, so the pollutants tend to accumulate over a certain space. So that is a problematic situation. But in case of your plume rise and the inversion condition is below the height of the stack, now what happens? Ki, for example, that this is your stack, and below this we have an inversion condition. So जो भी pollutants यहाँ से disperse हो रहे हैं, that will tend to disperse above this layer. तो what will happen कि इसके नीचे जो भी हमारा ground till the surface of the ground, यहाँ पर इस region में pollutants minimum होंगे. So in this condition, inversion is good for us. So it is a like condition based thing कि हम कैसे situation पर inversion को observe कर रहे हैं.
stack and chimney are the same thing, ma'am.
Stack and chimney are the same thing, correct? It's just a bit difference is that कि chimney हम थोड़ा lower height पे या like residential उसमें term में use करते हैं, and stacks we use for like industrial or for that is a more technical term. I think we are done for the day. If you guys are having any doubts, just wait for 5 more minutes, and then we can end this class. So I think Friday will be fine for you guys.
Ma'am,
Yes, ma'am.
Okay,
Fine.
okay. So same time or any other time you want?
Ma'am, same like from 7, if you do it, it's better.
From 7 to 9.
Yes, ma'am.
From 7 to 9. Okay, I'll try to take that from 7 to 9. Let's see. Okay, let's do it from 7 to 9. Okay, ठीक है. Okay, let's do it from 7 to 9. Are you having any class from like 6 to 7 or any other thing?
no, ma'am.
Ma'am, basically, sometimes, yeah, no class, ma'am. But sometimes it becomes very late after coming from the college. So that's
Oh,
why.
okay. No issue, no issue. How about Saturday? Are you guys free? Do you guys have any class in the first half of the day? Like because for me it's like on Saturday and Sunday I have no class, nothing, and I don't have to take any classes.
No,
So
first up, we're having classes, ma'am.
you have no
First up,
class.
we're having class in university, so it's difficult.
Okay, no issue. So we'll take it from 7 to 9 on Friday.
Okay, ma'am.
And also, please don't forget to share those topics that you want to be discussed in the next class so that I'll prepare the slides accordingly.
Ma'am,
Yes, Harsha. Okay, so I think you guys can leave this class and we're done for the day. See you on Friday, 7 to 9.
Thank you, ma'am.
thank you, ma'am.
Okay, see you guys.
Thank you.